For those of you who don't know who I am, my name is Jennifer Michalak. I'm the math consultant for the state of Connecticut. I've been in my role for just shy of 5 years now. Just a quick show of hands, how many of you here today were able to be at the first part, the first session of Focus on Content Standards? Okay, great. So we have many repeaters. If you weren't at that session, just as a FYI, hopefully the people that raised their hand will agree with me. It was very well received. We did record the first session of that, and we are in the process right now at the state in getting it uploaded to YouTube with the transcription and all of that, with all of the materials that were part of that session as well. So hopefully that will be completed within the next week or two, so it will be available to you on the state platform. Today what we're going to do is we're going to spend our time looking at the math practice standards. So although we're doing these in two parts, the first part was on the content standards and the second part was on the practice standards, they really are to be interrelated. They're not to be thought of as two distinct sets of standards. The practice standards really is going to be about what should students be doing. So when we look at, again, what is in our standards, there is the standards for mathematical content, which is what was discussed last time, and then there are the standards for mathematical practice. And these are what are habits of mind that should be occurring in order to create mathematically proficient students. The experiences that many of our students had, many of you had, many of the experiences I had, really did not prepare the masses, if you will, to be mathematically literate in the long run. And what we're finding is that we need to change our practice, and that is not an easy thing to do. So we're going to talk about that. In order to be able to effectively address the practice standards, we really have to understand the history of why there's the practice standards. So very often when people think of the Common Core, there is a misconception. And that misconception is that, you know, they kind of tossed everything out and kind of started from scratch and built up. That is actually not at all what happened. They looked at mathematics in other countries, as we talked about last time, and when it came to the math practice standards, they drew on two very important resources that had been published by the National Council of Teachers of Mathematics. The first one was the Principles and Standards for School Mathematics. It's a little hard to see up here, but that publication date was in 2000. And if you think about it, it wasn't until 2010 that the Common Core came to be. And then the other one was Adding It Up. So these two particular resources is really the driving force behind the standards for mathematical practice. So we're going to do a little bit of a dive into these two sources so that you can understand why the practice standards are the way that they are. So what the plan for today is, we're going to first understand what are the practice standards, what do they mean, and then we're going to do a deep dive into each of them, and we're going to look at what are teacher actions you should be seeing, what are student actions you're going to be seeing. We're going to look at snippets of video for all of those so that you can see it in action, and we'll have, you know, discussion around that. So in the NCTM Principles and Standards for School Mathematics, they focused on 5 important concepts: problem solving, reasoning and proof, communication, representation, and connections. And I'd particularly like to draw your attention to communication, because one of the things that happen is when the practice standards came out, and Math Practice 3, Constructing Viable Arguments and Critiquing the Reasoning of Others, people were like, oh, this is really new. But way back in 2000, communication and reasoning were what students should have been doing all along in mathematics. So what the process standards do is they articulated what these should be. So when we're talking about problem solving, it's applying a variety of strategies, right? That's how you solve a problem. You think of your toolbox of information, and based upon that, you apply what you need to know. When we're talking about reasoning and proof, we think of proof very often. You guys think back to your geometry days in high school with your 2-column proofs, and here's your statement, and here's the reason why you can say it, and all that. But proof can be and is much more than that. It's about making conjectures and using the structure of mathematics to make conclusions. Communication. Can you organize the mathematics and be able to communicate it effectively? For many of us, regardless of what our disciplines were when we first became teachers, the reality of the situation is that first year of teaching, you probably learn more of your content than you ever thought possible. Because when you suddenly have to communicate those ideas to students, you have to know it at a much different level than just to be able to do it. Representation. How can we represent mathematics effectively so that it can make sense, not only for students, but then in the long run? And then connections. We hear very often in mathematics, probably more than any other discipline, that mathematics is a building block, right? You have to know this in order to know that in order to know this. But what we've never done, or we've done very poorly historically in mathematics, is we haven't used those connections in order to help our students learn the new stuff. We expected that they were going to figure out those connections on their own. And they really didn't, because developmentally they weren't prepared for that. And they were never taught how to make those connections. So those are the process standards. When you look at the strands for mathematical proficiency, what do students need to have in order to be proficient? They need to have adaptive reasoning. They need to have strategic competence. They need to have conceptual understanding, productive disposition, and procedural fluency. So what do these mean? Conceptual understanding is, do they understand the underlying foundations of the mathematics? Conceptual understanding is about understanding how the mathematics fits all together and building upon that. It is not just being able to reproduce a rote procedure in order to solve a problem. Procedural and fluency is, can you carry out procedures, here's the key, flexibly, accurately, efficiently, and appropriately. There are certain times when the standard algorithm for multiplication makes sense. There are other times when that is one of the least efficient ways to do a problem. So if you don't provide your students with enough strategies to understand the concepts related, they don't understand how to be efficient. Strategic competence, can they actually go and solve a problem? Particularly a problem that's not familiar with them. So, historically in mathematics, it's, I do, we do, you do, kind of that gradual release model. But what we want to do is we want to be thinking about mathematics in a much different way, where they do it right from the chute. Can they handle that pressure to be able to solve a problem? And can they start to define what they need to know, and perhaps more importantly, what they don't know that they need to learn in order to solve the problem? Adaptive reasoning goes back to that being able to explain and justify. We know as adults, there's many different ways to solve many different types of math problems. There's not just a single solution path. Can I have my solution and explain it? You have your solution and explain it. And can we understand why both work? That's that reasoning piece. And then productive disposition is the habitual inclination to see mathematics as sensible, useful. That, I believe, is probably our biggest challenge right now in schools. Because as a society, and this is not just exclusive to Connecticut, this is a national, in my opinion, epidemic, where it has become culturally and socially acceptable to not be able to do math. We have many parents who come into conferences and they, if they have a student who's struggling in math, yeah, I know, I can never do math either. And that's okay. those same parents, if they had a struggling reader, would never come in and say, it's okay if my kid can't read. It's not acceptable in reading, but it's become very acceptable in the world of math. And that is something that I think we are all charged with starting to change. So, as I preface this, these are the two bodies of thinking and research that grounded the standards for mathematical practice. So what I'd like for you to do is to take out activity 1. It's the crosswalk activity. And what I'd like for you to just take a couple minutes, you can do this with partners, you can do it solo, whatever, is I'd like for you to read both of these. This was everything that was just on the last two screens. This paper in your folders, it's the top one. You don't need the folders, you don't need this yet. This is a later activity. So activity 1 is right on the right-hand side of your folder. And what I'd like for you to do is to either highlight, underline, circle, kind of what do you see as similarities between these two columns, if you will? What are the heavy hitters? The key verbs, if you will, that seem to really be articulating in both. So I'll give you just a few minutes to take a look at that. Okay, so if you had to come up with kind of some key words that describe the overlap between the process standards and the strands for mathematical proficiency, what are some of the things that kind of jump out at you in kind of both arenas?
I'm sorry, would you repeat the question?
Sure. What are some of the key words, or how could you maybe summarize the key similarities in terms of those process standards and the strands for mathematical proficiency? When you kind of look across the columns, what were some similarities you noticed in terms of what we're expecting students to do?
Under problem solving, the applying a variety of appropriate strategies, I think, goes hand in hand with the procedural fluency of flexible and efficient.
Yep, very good. There's a connection there. Other connections that you see?
I kind of looked at this as looking at them all together, and I guess what we're that we're developing a better conceptual understanding of math and moving away from rote and memory, and we're wanting students to develop the ability to explain and demonstrate their understanding through connecting the connections that mathematical ideas have.
Good, good. So they're representing and solving problems by formulating those solutions from everything that they know. Good. Anything else? Yep.
I saw similarities between the connections and conceptual understanding.
Yes.
You have to make those connections for students to be able to understand the concepts that are being taught to them. So.
Very good. So the one area, I think, that you don't see a connection between the two columns, if you will, is that productive disposition. That was kind of like the added thing, if you will, right? But that becomes very, very important because that leads into this idea of what we want mathematically proficient students. We want them to do all of these things, but in order to be able to do that, there needs to be a healthy disposition. So now what we're going to do is we're going to kind of take a deep dive into the standards for mathematical practice. Now here's something that happens very often in schools, and I'll be honest with you, I was probably a culprit of this because I was in the classroom when Common Core came out, and we all have our posters around our room that have the standards for mathematical practice. And that in and of itself, that's not a problem. But a lot of teachers spent a lot of time making sure that the students understood, we're working on, math practice 4 today, or whatever the case may be. And I used to tell my students, I honestly couldn't care less if they could recite the practice standard, because it was about them exhibiting the practice standard. So yes, the teachers need to know the practice standards and what all that's about, and the teachers should be or the students rather, should be understanding what is expected of them to be able to demonstrate what they're doing mathematically. But in terms of if they can articulate the language of the standard, that is irrelevant. They are never going to get an assessment question that says, what is practice standard 3 of the Connecticut core standards, right? So why do we waste that time and energy? So here's the standards. They make sense of problems and persevere in solving them, reason abstractly and quantitatively, construct viable arguments and critique the reasoning of others, model with mathematics. That becomes really, really important at the high school level. Use appropriate tools strategically. Okay? I always think of that idea of the calculator. You know, there's always been the calculator debate always goes back and forth. Give them a calculator, no, don't give them a calculator, no, give them a calculator, no, don't give them a calculator. The reality is if you use a calculator strategically and appropriately, the calculator is not necessarily problematic. It's if we give it to them without the conceptual understanding of why the calculator is producing the answer it's producing that we cause problems. Attend to precision, okay? We know that estimation is important, but there are times mathematically that you do need to be precise, and that includes the language of mathematics, okay? So make sure that your teachers, when you're listening them to talk about mathematics, that they're using appropriate vocabulary. Look for and make use of structure, and look for and express regularity and repeated reasoning. So how do these connect to these process and proficiency standards? Well, we can break them up. Math practices 1 and 6 are kind of your overarching ideas. They tend to kind of get embedded in everything else that we do. Those are your problem solving and precision. And if you go back to those practice and process standards or proficiency and process standards, you see that idea of problem solving straight through everything. And then the other 6 practices can be broken up into explaining and reasoning. If you go back to the paper that you just worked on, you see that idea of explaining and reasoning coming through. Modeling and using tools. That gets into your flexibility, that gets into your reasoning, and then seeing structure and generalizing. That's really getting into your conceptual understanding. Do they understand how the structure of mathematics gets you to the next point? So that's kind of the breakdown in terms of how you can group the standards. So what does this mean in terms of, great, I know what they are saying, but what does it look like and what does it mean? So they have a dual nature. There is, within the practice standards, content that we are expecting of our students. So as an example to that, the first one, make sense of problems. Students can explain correspondences between equations, verbal descriptions, tables, graphs, diagrams, and important features of relationship graphing data. Those pieces really span K-12, okay? Being able to look for those connections, and they're very specific about where they want to see those connections made. But beside the rather limited content, because obviously that wouldn't be enough content to produce mathematics for K-12, the other piece of the standards for math practice is describing the nature of the learning experiences, the thinking process, the habits of mind, and the dispositions that we want students to have. That's the piece that needs to be embedded in your instruction on a regular basis. It should not be, I'm going to teach you this procedure and then I'm going to teach you how to make an argument about that. It's embedded within. Using the same practice standard, students analyze given constraints, relationships, goals, evaluate their own progress, change course if necessary. Okay? In other words, we want to hear talking in math classrooms. If you walk into a classroom that is working, okay, obviously a quiz or a test, yeah, we want it to be kind of quiet there, right? But if they're working on learning a new concept, and it is as quiet as it is in here right now, that should be a red flag for you, okay? Organized chaos really is something we want to see in mathematics. And that's a challenge, particularly with teachers who have poor classroom management skills, because once you give that release, how do you get it back, right? And do students take advantage of that? So if you're not seeing that, think about ways to support your teachers beyond just understanding the practices, but is there some classroom management pieces that need to come into play, okay? So what I'd like for you to do now is I've copied for you for activity 2. This is directly from the Common Core standards. And what I want you to do is I want you to read the first sentence of each statement. So not the bold, the first line after the bold for each statement is what I want you to do now. So what did you notice about the first sentence, and more specifically, the first 3 words of every single practice standard? Mathematically proficient students starts every single standard. So these practice standards are truly about what the students are able to demonstrate. And just like anything else that we want students to be able to demonstrate, the learning experiences that are set up by the teacher dictate if they will have the opportunity to demonstrate that and to gradually build the skills necessary to do that. So what do we want them to do? Here's kind of part 2 of going through these standards. This is our deep dive. This one will take a little bit longer. As you go through, now I'd like you to actually read the whole paragraph. And as you go through, I'd like you to summarize with just a few key words each practice standard. And I've given you kind of a sheet to help you do that. Okay? What are some of those, simple key things in terms of, if I didn't want to read this whole thing, what could I tell somebody? Basically, this is about doing what? Kind of those few keywords. But then more importantly, I want you to think about where your teachers are at in your buildings or in your district. And what is the impact on instruction that practice standard has? So what that may look like when we're talking about impact on instruction, maybe that's, if we're talking about explaining reasoning or whatever, that we have students who, we need to ensure there's times that students can defend themselves within the lesson, or things like that. Okay, it's what are the types of learning experiences that need to be implemented in order to be able to build that practice. So I'll give you guys about, 10, 15 minutes. Read through, summarize, and then think about that impact on instruction. What type of instruction is going to facilitate that practice standard's evolution? Okay, if I can bring everyone back for a minute, because I really want to spend some time really thinking about not only what the practice standard is expecting students to be able to do, but more importantly, what does that mean for our instruction? So that way, when you go back to your buildings, whether you're in the role of a coach, a building principal, or if you're a district person, How can you ensure that these practice standards are being attended to? Because as we go through our morning together, you're going to see how these practice standards have a direct relationship to the Smarter Balanced Assessment. So if you're not attending to these, you're going to be setting yourself up for problems on the assessment to which you're all accountable to. Whether we like it or not, that is the accountability. So let's take a look at these. Now, I'm going to give you very brief summaries. I know many of you probably wrote more, which I think is good. But in terms of the context for the whole group, I don't think we need to get too detailed. So for Math Practice 1, the summary is that we want students to be able to explain and make conjectures. So if that is ultimately the goal, what types of learning and experiences, or how does that impact instruction for a teacher? If we want students to be able to explain and make conjectures. Any ideas? Any thoughts that were going through your head? If I want students to be able to explain and make conjectures, what do I have to do?
You have to encourage lots of discourse within the classroom.
Yep, lots of discourse.
Teach them how to fail and reevaluate.
Yeah, that whole idea of like mistakes are okay. I actually find your high performers struggle with that a heck of a lot more. The high performing students are the ones that are like, please just tell me what to do and I will create it for you. It's not a problem. Do not make me have to think on my own, because if I don't get it right, I'm very uncomfortable with that.
Encourage students that there are a variety of ways to arrive at a solution. There's no one way. And so that what they're thinking or doing, just because this person isn't doing it or that person is doing something different, that doesn't make you wrong.
Correct. And so that also goes back to that whole idea of planning for instruction, planning strategic tasks that have multiple solution paths of entry, right? To be able to build that competence in kids.
Having students work in small groups so that they can see how each other practice on how to solve for particular problems.
Yep.
We could model it ourselves. We could kind of talk through the process that, what we would say in our head is we're trying to solve the problem. What do we know? What don't we know? Why?
Yep.
Why does this answer make sense or not?
Good.
Make sense?
And I think the only thing that I would say that hasn't been touched upon yet is, and this is hard for some teachers, is the teachers need to stop talking so much, right? So I agree when you're going over something that outward thinking in terms of modeling, I do agree is crucial. But once we start getting into the problem, the teacher has to know when to give up that control, right? Like, I'm not going to say anymore because I need you to be thinking. Because the way that I go about this problem looks like this, but that might not be how you go across that problem. The most challenging math courses I taught, I've taught everything from 8th grade mathematics up to and including AP Calc and computer science. And some of the most challenging ones were when the students didn't do it the way that I did it. And I'm like, oh my God, did this just work just because they got lucky? Or like, is this mathematically sound? I don't know, because I didn't think of the problem this way, right? So you're up in the front of the room, the kids say, oh, I did this. And you're like, oh my God, I don't know, right? And that feeling of I don't know is what our kids go through all the time. So we have to build that opportunity, as you were saying, that no, you can talk about it. Just because I did it differently doesn't necessarily mean that I'm wrong. All right, moving on to Math Practice 2. Make sense of. What types of learning experiences do students need to be participating in so that they can make sense of the content?
They need real-world application opportunities.
Yeah, they have to see how it relates to their life. Because now, oh, that makes sense why I need to do that. I can connect that to something that's important to me, right? If it's not important to me, why would I care if it makes sense or not? Okay. How about understand and use? So keep in mind, math practice 3, again, is that construct viable arguments and critique the reasoning. Yeah, when you read through it, it really is about understanding and using. So what types of experiences do students need to have, or what types of structures do your teachers need to have in place in order to promote them understanding and using? What do you think?
Well, I think they need time to look at the different ways problems can be solved and talk with their peers about, hey, you solved it that way, I solved it this way. Maybe the answers are different, analyze it for errors, just talk about it.
Yeah. I heard a conversation going on over here as I was walking around where someone had said it's nice to look at presenting a different way to do a problem and having the students be able to figure out, which is the understanding, right? How does that relate to how you did the problem? Can you still do it that way? Now the caution there is, while I agree we need to be providing a toolbox of information for students, we also have to be really careful that we allow them to actually use what makes sense for them. I think too often, and this is one of the complaints we're seeing when Common Core hits Facebook, is that teachers are teaching a bunch of different strategies, but then requiring that the kids do all the strategies all the time. Why? What's the purpose in that? The purpose of all the different strategies is about building that flexibility and being able to make sense of the mathematics and being able to get to that end game, right? So why, if one student happens to understand it one way, and the idea with that whole explaining and student talk is that you hope through that they're going to hear something that's like, oh, I didn't think of it that way. That makes sense. And wow, that would have saved me a boatload of time. I wish I did it that way, right? So now we build in that flexibility piece. Okay, so just be very cautious as you're watching your teachers. Are they mandating that students are solving a single problem? You know, do it this way, and this way, every single time. Now, granted, there needs to be some familiarity with the different types of strategies so they become comfortable. But at the end of the day, do they actually have to have mastery of all of the strategies? I would argue no. Okay, how about apply and interpret? So this is related to Math Practice 4, which is about modeling with mathematics. What do we need students and teachers to do if we're going to be building this idea of applying and interpreting? What's the impact on instruction for apply and interpret? Yep.
We need to provide time for the kids to grapple with the idea and to work in those small groups and apply their thinking to make sense.
Yeah.
Working on
If you're going to be interpreting something, it takes time, right? Because you have to figure out kind of what's going on. Like, what are all the constraints? What's happening here? And then figuring out what I might even have to apply in order to be able to take that a step further. So time is really important. What's the biggest lack of resource in any school? It's not money. It's not a textbook. It is time. That is the leading deficit for schools. So you want to make sure that your lessons provide that time. That provides a different way that teachers have to think about how they teach mathematics. Again, we have to get away from this lesson is one day I've got to get through it because that's what my pacing guide says. We have to, as the educators in the building, we have to be in charge of figuring out where are their connections so that I can build a lesson around those connections and provide my students with the time necessary to grapple with it. That's on us. That's an adult action that needs to happen. That's not on a kid action. Okay? And understanding when is it appropriate to kind of move on, right? Because that's the hardest thing. As teachers, as principals, we all want our kids to learn it all, right? But there does become a point, if you think of kind of bringing back our last session with the progressions, that they have the basics they need to be able to move it forward. Okay? Consider and detect is math practice 5, which is about using appropriate tools strategically. So I think where this comes in is, I'll think of, I'm going to say elementary, but for those of you who are secondary folks, get those manipulatives out in your middle and high schools. Like, it's like taboo at high school. I taught Algebra 1, right, in 8th grade. I used algebra tiles all the time in my classroom. Taught the same class that the high school teachers taught. High school teachers never took the algebra tiles out. We don't need manipulatives here. Why not? Because guess what? If they can use a manipulative because that helps them make sense of it and gradually builds that understanding, what's the problem in that? And more importantly, don't force it. Here. I've seen in elementary schools, you have maybe your pattern blocks out, you've got your base 10, all these stuff. You have stuff out. And expecting the kids to figure out, you know what, I can use this because I think it's going to help me. There's going to be other students in your room who they don't need those supports because cognitively their brain is processing that mathematics differently. That's okay. But that doesn't mean just because I need the support right now that I can't have it. Communicate precisely to others. Okay? The impact on instruction, again, think about having your students summarize the lesson. So back in the day, I'm going to date myself, back in the day of BEST, how many of you were BEST trained? Maybe either went through the program or, okay. So like the big thing in BEST, right, when it first came out was closure. Like people set their timers to make sure they had those 5 minutes of closure because they would get you every time, right? Closure's important in any lesson, but here's how we need to rethink that. I, as the teacher in the front of the room, I don't need to do the closure. I want my students doing the closure. I want them communicating what they learned in their lesson. That's a way that I can figure out, did my lesson work, or do I have some reteaching to do? And it allows my students to communicate with each other about the math. And sometimes what you see happen, which is like the beauty of it, is you get someone else who says, yeah, that's not exactly how I understood it. What about this? And now you bring back all these other ones that we've already talked about. Okay? So it's really about training teachers to understand that they are facilitating the learning and not giving it away. And that's a big shift. Discern and recognize. That becomes a matter of making sure that your teachers are providing a bunch of different types of problems. We don't want to see the worksheet that has 30 problems that are exactly the same. Because yeah, your kids can do those 30 problems. They'll probably be great at them. But you change one look, something as simple as a multiplication problem, writing it horizontally versus writing it vertically, that will throw some kids right out of the water. Like, nope. And then we get in trouble at the state, when I say we, because when you work for the state, you become the state. I don't have a name anymore, I'm the state. We at the state, Smarter Balance, well, how are they going to present that? Because, my kids don't understand it that way. Well, why not? Because you're not providing them opportunity to discern and recognize other ways that it could be presented. And it shouldn't be, and this, again, so that's a time issue, right? Well, why do we have to present, okay, here's one way, and then the next, okay, now this looks different. Mix them up. Right from the beginning. It's the same content. So why get their brains thinking rigidly? Mix it up right from the beginning. And then the last one is notice and pay attention to. I think particularly math practices 7 and 8 are most significant at the secondary level. Because when you get into understanding the structure of mathematical equations, quadratics, linear, exponential, understanding that the format that one of those equations is in gives you different information about the problem. When students can recognize that, that increases their proficiency. So for instance, and I know not everyone in here is a math person, so that's okay, but if I'm writing a linear equation, I'm gonna go to my 8th grade, if I've been given point and slope versus given slope and intercept, I can use 2 different ways to do it. I can use point slope form, boom, there's your equation, done. Or I can use slope intercept form if I was given something else. That flexibility really comes about with noticing and paying attention to, oh, okay, that's why that's that way. Okay, which again, similar to math practice 7, keep in mind those are kind of grouped together, that has to do with presenting things in a variety of ways right from the beginning. Back when I was a kid in algebra class, we spent all this time on slope intercept form. Now we're going to do point slope form. So the takeaway from the child is this is different. It's not different. It's a different structure, but it still represents a linear equation.
One of the things I'm wondering is, like, if traditional math instruction is bench purpose towards solutions, then our students are not wrong in just wanting one efficient way to get to the solution, because that's what their grade is based on. I think part of this is, I would see is changing in a math classroom what determines a student's grade. That it's not just, I got the solution.
Right.
I mean, should we be assessing, I approach a situation, what are the types of questions I'm able to ask?
Absolutely.
Or I approach a situation and develop a possible plan to attempt to solve. We're assessing the plan without even necessarily assessing the solution or whether or not it
Yeah, I would definitely encourage you to present problems or experiences for students that don't have an answer or you don't need an answer to, similar to what you just described. Or problems that have multiple different possibilities as answers that are all legit, because that happens too, right? So yes, I would definitely be encouraging that. Now again, when we're talking about precision, there are some times where you do need to get an accurate answer in mathematics. But I agree, historically, it's always, I just need to get to the answer. Nothing else matters as long as my answer is correct. And I'll agree with that, but we need to think about those processes in order to be able to demonstrate true competence. Now, there are some students who are going to be able to go from the problem to the solution very quickly. We shouldn't, I don't think, be discrediting that either, but we should be asking those follow-up questions. So what did you do? Like, what went through your head to do that? So yeah, and I do agree with you. There are some restructuring. We're not going to get into the grade debate because obviously that could take us until, like, I don't know, yeah, the rest of the day and beyond. But I agree, we do need to think about how are we assessing students in math, and are we including assessment of the practice standards within it? All right, so now we're going to, now we've had a time to, we've read through the practice standards, we've summarized them, we talked about the impact on instruction. Debbie Wagner put this together, and this is a fun activity, at least it's supposed to be fun. It's one of my favorites. I thought about cutting it, but I just can't because I enjoy it too much. So, Debbie Wagner took clips, which we're going to see in a minute, from The Big Bang Theory, okay, which is probably one of, in the modern day, what's given math a little bit of, we can do math because now, we have Sheldon and we know how brilliant he is. So what this is going to do is it's going to bring you through the 8 practices, not in order. And your goal throughout this is to be thinking about what you know about each practice standard and identifying which practice standard is being evidenced in the clip from Big Bang Theory. And then we'll talk about it.
Returned any of my calls because I hadn't offered any concrete suggestions for pursuing our friendship. Yet perhaps the two of us might share a meal together. Yeah, I see. Well, then perhaps you'd have time for a hot beverage. Popular choices include tea, coffee, cocoa. I see. No, wait, don't hang up yet. But what about a recreational activity? I bet we share some common interests. You tell me an interest of yours. Really? On actual horses? Tell me another interest of yours. Oh, no, I'm sorry. I have no desire to get in the water till I absolutely have to. Tell me another interest of yours.
Uh-oh, he's stuck in an infinite loop. I can fix it.
Tell me another interest of yours. Is there any chance you like monkeys? Yeah, what is wrong with you? Everybody likes monkeys. Hang on, Kripke. A loop counter and an escape to the least objectionable activity. Howard, that's brilliant. I'm surprised you saw that.
Gee, why can't Sheldon make friends?
Accelerating backwards through time is fascinating.
Thank you. It came to me one morning in the shower.
That's nice. Too bad it's wrong.
What do you mean wrong?
You made an arithmetic mistake on page 2. It was quite a boner.
No, but that can't be right. I don't make arithmetic mistakes.
Are you saying I do?
Oh, no, of course not. It's just, I was thinking, oh gosh golly, I made a boo-boo. And I gave it to Stephen Hawking.
Great. Another fake.
Why Sheldon Cooper, PhD, should go to Switzerland to see the CERN Super Collider. A PowerPoint presentation by Sheldon Cooper, PhD.
Oh, for God's sakes.
Here we have a highly gifted researcher in the field of particle physics, whose work has brought him to the precipice of forever changing mankind's understanding of the universe, aka me. And here we have a waitress brushing her teeth with her finger, aka you.
I'm sorry, is this supposed to be buttering me up?
Please hold all questions till the end of the presentation. This is the Large Hadron Collider at CERN in Switzerland, the product of decades of planning and construction. It is a mecca for physicists the world over. This is Bath and Body Works on Colorado Boulevard. They sell scented soaps and lotions, some of which contain glitter. Now, let's see if we can match the individual to the appropriate destination.
Okay,
The best number is 73. You're probably wondering why.
We're good.
73 is the 21st prime number. Its mirror, 37, is the 12th. And its mirror, 21, is the product of multiplying, hang on to your hats, 7 and 3. Huh? Did I lie?
We get it. 73 is the Chuck Norris of numbers.
Chuck Norris wishes. In binary, 73 is a palindrome, 1001001, which backwards is 1001001. Exactly the same. All Chuck Norris backwards gets you is Ciron Cook. I feel very comfortable around you.
I feel very comfortable around you, too.
It's surprising because I generally don't feel comfortable around, well, anyone.
Nor I.
What are the odds that two individuals as unique as ourselves would be connected by someone as comparatively workaday as your son?
Is that a rhetorical point, or would you like to do the math?
I'd like to do the math.
Sheldon?
What?
I need an aspirin.
Top desk drawer.
Thank you.
All right?
Yes.
Good. Overlook the fact that she is an arrogant, subpar scientist who actually believes loop quantum gravity better unites quantum mechanics with general relativity than does string theory. You kids have fun.
Hang on a second. Loop quantum gravity clearly offers more testable predictions than string theory.
I'm listening. Amuse me.
Okay, well, for one thing, we expect quantized space-time to manifest itself as minute differences in the speed of light for different colors.
Balderdash. Matter clearly consists of tiny strings.
Okay, well, there's a lot of merit to both theories.
No, there isn't. Only loop quantum gravity calculates the entropy of black holes. You agree with me, right? Loop quantum gravity is the future of physics.
Sorry, Leslie, I guess I prefer my space stringy, not loopy.
Well, I'm glad I found out the truth about you before this went any further.
Truth? What truth? We're talking about untested hypotheses. It's no big deal.
Oh, it isn't really? Tell me, Leonard, how will we raise the children?
I guess we wait until they're old enough and let them choose their own theory.
We can't let them choose, Leonard. They're children.
How many Superman movies are there?
You're kidding, right?
You know, I do like the one where Lois Lane falls from the helicopter and Superman swooshes down and catches her. Which one was that?
One. You realize that scene was rife with scientific inaccuracy.
Yes, I know men can't fly.
No, let's assume that they can.
Lois Lane is falling, accelerating at an initial rate of 32 feet per second. Superman swoops down to save her by reaching out two arms of steel. Miss Lane, who is now traveling at approximately 120 miles an hour, hits them and is immediately sliced into 3 equal pieces.
Unless Superman matches her speed and decelerates.
In what space, sir? In what space? She's 2 feet above the ground. Frankly, if he really loved her, he'd let her hit the pavement. It'd be a more merciful death.
Excuse me, your entire argument is predicated on the assumption that Superman's flight is a feat of strength.
Are you listening to yourself? It is well established that Superman's flight is a feat of strength. It is an extension of his ability to leap tall buildings, an ability he derives from exposure to Earth's yellow sun.
And you don't have a problem with that? How does he fly at night?
A combination of the moon's solar reflection and the energy storage capacity of Kryptonian skin cells.
As I said, this was a fun activity, but what I'd like to do is I'd like to talk about it because I think that it does really give a nice depiction of what these practice standards are kind of about. It's a good summary. So, for the first one, make sense of problems and persevere in solving them. Which clip do you think was trying to exhibit that perseverance piece? F, yeah, F was the one where it was playing like the Rocky in the background, you know, like they just kept sticking with it and sticking with it. And you may have walked into some of your classrooms and kind of see that same level of frustration, not only on the part of your students, but maybe sometimes your teachers too, right? Okay, how about reason abstractly and quantitatively? Which one had reasoning involved?
I selected D.
D, which was the best number. Okay, there was some reasoning in D. That's not the one that they're thinking here, but I agree that there was reasoning involved with that because he kept justifying why it was the best number. H, Superman, the one we just saw. Okay. How about constructing viable arguments and critiquing the reasoning of others? G, the loop versus string theory, right? No, this one's better. No, this one's better. Trying to figure out where we meet in the middle. How about modeling with mathematics?
A. I don't remember anymore.
Take.
I'm so busy watching.
I know, because they are so entertaining. It wasn't A for that one. Anyone else had a different one? For the modeling, it was E, which was the do the math, because that was the one, do the math was like, what are the odds that? And so we're going to like model this relationship here because this is so weird that it would happen. That one's a little tricky.
What was A? Since many of us said A.
A was the friendship algorithm with the chart. So we'll go back to, obviously that one's coming up in a minute, so think about that. How about using appropriate tools? That one should have been a little more obvious. Using appropriate tools, which was the one where they used, C, the PowerPoint. They used a PowerPoint presentation to be able to make a justification. That was the tool that they choose to use. How about the attend to precision, which I think is perhaps one of my favorite clips of the whole thing. B, with Mr. Hawkins. We made a mistake on page 2, right, of like this, 30-page document. And how many times does that happen in a classroom where in long problems, the mistake is very early on, which goes back to that idea of, is the plan or the process still present? And what happens with that? Look for and make use of structure was the one that was A. Okay, so we were in this infinite loop, so we needed an out, so we're changing the structures there to fit our needs. And then look for and express regularity and repeated reasoning. That was D, the best number one. So he gave all these different reasons why 73 was the best number, and it all had to do with the structure of the number 73. Okay? So again, that's just a fun little activity to... Yes, if you're here, you'll get the entire presentation and you'll get the key, you'll get it all. I will be doing that. Okay. So, now that we've had a chance to look at these practice standards, kind of see them in represented in a fun way, we now need to think about what does this mean for our classrooms and what does it look like in our classrooms. So as administrators and coaches who are supporting your buildings, what should you be seeing, or how are you going to begin to identify which practice standards need more emphasis in your classrooms? So, successfully implementing the standards requires the following. Teachers' knowledge of math language and content. That remains a concern in many of our buildings. So what are ways that we can build that math content and language? Teachers' knowledge of how to promote student involvement with the math practices. That goes back to what we were talking before. What are those learning experiences that we can set up that will promote the use of the practices by the students? Shifting the students' focus from answer getting to solving problems. Okay, we talked about that was in the back. And establishing a classroom environment as a community of learners. Mistakes are okay. I feel comfortable sharing my solution path because I don't feel as though I'm going to be judged. Okay, listening to your interactions of your teachers when a student gives an answer that's an error is important. If your first response from your teacher is, no, that's wrong, we need to go back and think about that. The first response should be, how did you get that? And then, did anyone get anything differently? I got this. How did you get that? Because now you can see where all the thinking, and the hope, quite honestly, is that the child who had the error figures that out before you even get a chance to circle back to them. So, implementing the implementing the practices, they need to be embedded in the classroom instruction. It is not a separate entity. It becomes part of the lesson. So just as your teachers identify, perhaps depending upon your structures in their lesson plan, what content standards they're focusing on, what practice standards are front and center in that lesson, okay? They're not a checklist. I did this, I did this, I did this. It's a habit of mind, okay? So there's going to be, and there should be, multiple things, multiple practices happening within a single lesson, okay? Now, we've talked in the last session that there is a progression of content. There is actually a progression of the practice standards as well. And I've provided the link, but I've also copied the resource. It's the first document behind the PowerPoint, where it goes through every practice standard and gives a description of what does that look like in kindergarten, first grade, second grade, third grade, fourth grade. Because if we're talking about critiquing the reasoning of others, critiquing is going to look very different in a second grade classroom than it will in a sixth grade classroom. And it should. So this was something that was put out, I believe it was Washington State, put this document together. And I think it's a really nice way for your teachers, especially if you ever have the luxury of doing some vertical teams. How are we building these practice standards as we go up? Okay, so that is a resource for you to dive in at your leisure. When we're talking about lessons really are implemented through two categories. The tasks by which your teachers are choosing to teach the content of the lesson, and then what are their actions that are actually implementing that task. So when we're talking about tasks, we want to make sure that the tasks provide an opportunity to engage in the practice standards, and they contain elements that speak to specific math practices. The teacher action is, what is the teacher doing to help facilitate those practices within that task? So what we're going to do now, another resource. Questioning, and effective questioning more specifically, is an area that if you can develop and professionally develop your teachers to become better at, a lot of this will fix itself. So the next resource that was put out by Wichita Public Schools has a summary of what the practice standard is, and then questions that relate to developing that practice standard. So if we have a task that we know should be developing modeling with mathematics, what might be some questions your teacher might want to incorporate within that lesson? Okay, so effective questioning is critical. This is a little quick resource that you could certainly share with your teachers to say, are you asking these types of questions within your class? Not every day. You know, we're not going to be like, oh, okay, do the numbers used in the problem, what do the numbers in the problem represent? But are we hearing that periodically? That's what we want to be thinking about. We want to make sure that the questions encourage students to think about their thinking and express their thinking. We want to get away from the questions that are, what'd you get for number 4? 12, okay, great, what'd you get for number 5? That's not doing anything, that's checking. You want to do that, throw your answers up on a smartboard and have the kids check it. That's all you're doing with those types of questions. You're not getting at the thinking. Now, there's a time for that, but if we're developing the math practices, there's also a time to ensure that the questions are better. So, what do classrooms look like? What we're going to go through now is we're going to go through each practice standard, and with each practice standard, we're going to talk about what is required of it. Then we're going to actually take a look at what it looks like in practice. So if we take a look, if we're developing a task or choosing a task, okay, so we're talking about tasks and teacher actions, and then we're going to see it in practice. Excuse me, so if we're looking at a task, if we want students to be able to make sense of problems and persevere in solving them, we want to require students to engage with the conceptual ideas. We want to make sure that the problems require some degree of cognitive effort. You hear a lot of terminology that's called productive struggle. Okay, that's kind of a coined term. We want that productive struggle. That is the hardest thing for a teacher to implement because teachers want to help kids, right? Like, that's why you go into the profession, because you want to be there for kids. And to watch kids struggle and be able to pull back and let them continue to struggle instead of just saving the day is a very difficult and uncomfortable thing for a lot of teachers. Encourage multiple representations, what I was talking about before. Have stuff out, right? School should be fun. Have stuff out that can help them. Encourage them to draw pictures to represent the problems. And require students to access the relevant knowledge to be able to work through the task. Are they able to pull from that toolbox? And if they can't, what tools are missing that we need to provide to them? How does a teacher do it? Allow students time, we heard time come up a lot, to initiate a plan. Instead of we hear a lot that people say, well, they're struggling, so I scaffolded the problem. No, what you did is you gave them the plan. You didn't give them time to think about the plan. Continually ask students, does that make sense? Is it working for you? Particularly if a student's getting stuck. Why are you stuck? What happened here? Question students to see connections. Is this like something else we done? Do you remember when we did this? And then consistently ask to defend and justify. The best way a teacher can answer a student's question is by providing a non-answer. We talk about turning the question around, right? For kids, they're supposed to turn around. Turn around as a teacher. I got number 4, is that right? You got number 4, do you think it's right? Why? It's all about that questioning and that interaction. So let's take a look. So what I have for you, just so, because most of you are in a position where you are also evaluators. So we're serving, I'm not talking evaluation at all, but as evaluators, I know that you guys have been trained and you're like, I need to be looking at things and I need that paper to record things. So what I've done is I've provided you with a little bit of a recording sheet. It's marked number 5. We're going to use this for the next while. We're going to watch a clip from a classroom. I'm telling you up front, this is math practice 1. Or at least there are some pieces of it that are math practice 1. You might see some other practices. But what are you seeing as either teacher actions or student actions that are exhibiting what we want to see in math practice 1? Okay, so this is really that, can I identify it in practice so when I go back to my buildings, if I'm not seeing it, I can figure out ways to support my teachers. Okay? So what did you see the students and the teacher doing that shows that math practice 1 is evidenced in this classroom? Let's start with the teacher. What were her strategic moves that promoted math practice 1, which remember is persevere in solving problems?
Valuing different solutions.
Yeah, encouraged her teachers or her students to share their different approaches. And even when people are like, but you can just do this, she said, wait a minute, let's stick, I think it was Marlene was the little girl's name. What did you do next? So she gave Marlene that confidence that, you know what, they're saying something different, but don't question what you're doing. Let's work through this together.
She was unreactive.
Yeah.
So she didn't say, right, or, let's think about that again, or it was just very straight information.
Yep. What else?
Whole questioning techniques.
Yep, her questioning techniques were good.
Very open.
She also, when they started to go over with Marlene's problem where we're breaking it down in the 10s and the 4s, and Marlene explained the 4s, a different student then explained that she had to do the 10s. So that's making sure that the other students are understanding that approach as well. Okay? Good. This is where it's just going to get...
We're unable to see all of the video. Did she further discuss the wrong answers that were on the board and see how the students were arriving at that?
I haven't looked at the entire video myself yet, but this entire video lesson, and these links are here, are available. Yep. Okay, so the next one is reasoning abstractly and quantitatively. What type of tasks or what do we want to think about in our task selection to do this? We want to include questions that require students to attend to the meaning of quantities and their relationships, not just how to compute them. Okay? So some of that is some of those key words. We're all used to doing the key words where, what are all the things that might mean plus, altogether, sum. Yeah, we get that, but we want to think about what is the relationship between quantities, not just looking for keywords. Consistently expect students to convert situations into symbols in order to solve the problem, and make sure that they can explain their solution for the meaningful situation. So we know mathematics is very symbolic in nature, right? I mean, a number is a symbol for something, for a quantity. Our operators, add, subtract, multiply, and divide, those are all symbols. Do they understand what the appropriate symbols are to use and why? And then it contains relevant and realistic content. That's what we had talked about before in terms of if we want to reason, we have to give students something that makes sense to them. We don't want to give them something that's not at all in their wheelhouse and expect them to reason about it. Okay? I'm not a lawyer. Okay? So if someone asks me a legal question and wants me to reason about whether or not I should do something, I have no foundation to do that. I have nothing to draw on. So you want to make sure that things are pretty relevant to them. How should the teacher do it? Ask them to explain. Again, you see questioning coming up all through this. Have students give meaning to all the different quantities. We know that very often there's distractors, but what is the purpose of those distractors? And then, again, do they understand the relationship between things? So one of the things we find when it's about reasoning, and I chose this clip partly because of this reason, this clip is going to be, first of all, it's going to be high school. Second of all, it's going to be an EL classroom. Because we hear very often, whether we're talking our L population or others, but the kids can't read, and so that prohibits them from getting at the math. Again, that becomes a teacher action. If there are words within a problem that students don't know, because either English is not their first language or they're struggling, that needs to become part of the instruction. So we're going to take a look at this clip from a high school, I think it's an Algebra 1 EL class. Now obviously if you're not Spanish speaking, you might not have picked up on a lot of that, but you can still just look at the interactions. We're talking about reasoning. Okay, so reasoning is getting at the thought process, and it is about making sense of the quantities. What did the teacher and or the students do that is indicative of that reasoning? Any ideas?
He was asking why a lot, and obviously he said porque.
Right.
So I have basic knowledge of the language, but he would, especially in the beginning, he was really focusing on the why and understanding, and he alluded to pushing them to engage in that process of why.
Correct. Okay, and the why gets at the reasoning. What did they reason about that in order to be able to make that conclusion? What else? What was that?
He talked a lot.
He did talk a lot. He did talk a lot. And in some instances, we've talked a lot about less teacher talk, right? So, but it was the way in which he was talking, he was going through it. What about when he found the error on the student's paper? How did he end up really talking about the reasoning and about the quantities with that? Did anyone pick up on what he had said?
What are you trying to solve?
What are you trying to solve? And then what did he say about 3? 3 represents the X, right? Is what he said. So why do you have it in the Y? That is that understanding of relationships. What is it that I'm trying to solve? I found my X, but I put it where Y is. So am I really understanding that relationship? Okay, so that's what we were getting at there. So math practice 3, as I mentioned previously, really is the one where I think so many schools went like all in on math practice 3, and we're just going to make sure we do math practice 3, and it was only about math practice 3. So with math practice 3, this is constructing the arguments. You want to make sure that your tasks bring out multiple representations. You want them to be as open-ended as possible in order to be able to get to that point of being able to justify and have creative discourse. Embeds discussion and communication of reasoning. If you are doing math practice 3, you should be hearing a lot of student talk about mathematics. Requires that the students provide and explain their thinking, okay? And give feedback on other kids' solutions. So here would be an example of a task. Joel and Marissa are running for president at their middle school. After the votes are in, Joel and Marissa are each convinced they've won the election. Joel argues he has won a larger percentage of the overall vote than Marissa, so he should be the new president. Marissa argues that she has won a larger percentage than Joel of the 6th grade vote and the 7th grade vote. Since the majority of the grades voted for her, she should be the new president. Is it possible that they are both correct? There are no, well, other than 6th and 7th grade, there are no numbers in this math problem. Uh-oh. So this is really getting at multiple solutions. This is getting at, does it matter what the numbers are? Because as you go through this thinking with the students, someone said like that modeling, what am I thinking? Maybe you're going to throw some numbers in. Well, what if it was this? Would that reasoning hold? So teachers' actions, again, asking questions, peer evaluations. You can do partner work. We talk about, a strategy, turn and talk. This is an appropriate time for turn and talk. Okay, you've solved the problem, Go ahead, turn about and talk about your solutions that you did independently. What are the commonalities? What are the differences? Let's take a look at math practice 3. And this teacher is a 1st grade teacher. Okay, again, purposeful in my selection because we don't always think of 1st graders being able to justify themselves. But you're going to see here where she's able to do this. First grade. Okay, so obviously constructing and arguing and justifying in 1st grade looks very different than it might look in other grades. But what was she doing to get the kids to be thinking about how they would justify their solution? What did you see the teacher doing?
She gave sentence starters to put them in a position to be able to create an argument for each other in a non-judgmental way, but a way in which way they could describe to each other their findings and then.
Yeah, she put it into their terms, right? Like she didn't say, okay, now you're going to make an argument on why you're right. The kids would be like, what? Okay, so she got down to their cognitive level. She provided those supports and structures to be able to encourage them to talk to each other. What else did she do? Anything else that you saw or the students doing?
She modeled some responses so that the kids would know how to properly answer. And then when she asked for one of the kids to respond, she came back with, well, how do you know?
Yep.
Trying to get them to push their reasoning.
Good. Anything else that you saw there? She kept, oh, go ahead.
The structure, because they're doing it in partners, I think lends itself, especially in first grade, to like kids evaluating wrong answers because they don't have a filter at that age. So they'll call each other out when the answer is not correct.
Correct. Yep.
I thought she had very good wait time also. Trying to say 5 plus 5 equals 10, but it took him a little while before he got that.
Yeah. Yeah, our young elementary, or our early elementary teachers, like, they're saints. I taught middle school and people are like, you are crazy, which there is probably some craziness there. But I'll tell you, people who teach that K1 too, they're saints, because you're right, you have to wait. The students are still learning how to articulate appropriately, right? So you have to provide that time. So this teacher did a very nice job. And in none of these clips are we saying that like this is, the perfect lesson or whatever. There's certain things that obviously there's always improvements that could be made. But the idea is that we're really just trying to hone in on what supports did the teacher put in place and the evidence that the students did that really shows that practice. Moving on to math practice 4. This is structured so that students represent the problem situation and their solution symbolically, graphically, pictorially. You want to make sure that they can go up between representations and still understand what's being said. This definitely invites real world problems, right? That's the whole purpose of modeling, right? You model real world situations. And we're taking something that may seem very complex and we try to break it down into a model that makes it easier to understand. So the teacher really will be showing how they model things. Give free choice. Let the students pick what model's working for them, but ask them to explain why they chose that model. That starts to then also build that flexibility piece. The appropriateness of the model. Is that an appropriate model? One of the things that I loved teaching about problem stat when I was in the classroom was, I always say you can make statistics lie, right? You want to show something. For those of you that have to present to your board members, remember this, change your scales, because you can make the littlest growth look really, really big. Just use a different scale. And most people don't pay that much attention. They just see the line going up a lot, right? So you have to be very thoughtful. So that's that reasonableness. Well, how come their line is so steep and yours isn't? Why? What's the reason for that? They both did a line graph as their model, right? So you have those types of conversations. All right. And this is, I really try to come up with people at different grades. Which grade was he? I think he's middle school. We won't watch again. We won't watch all of it, but I think it's important for you to see it in action to start to pull out those pieces. So this is middle school. What model was he actually using here? What was the construct of the model? Table, okay? So it doesn't have to be a graph. A table is a model.
I think his focus in terms of explaining how you set it up makes and promotes the students diving deeper into the understanding of where this model's come from. Not saying you have to do it this one particular way, but to support your reasoning of why you chose this.
Right. So how many times when we want kids to fill out a table do we provide all the parameters? Right? We say, okay, here's your, using this kind of idea of DVDs, here's your number of DVDs, here's each plan, now just fill in the table. Maybe providing students with some opportunity. And then when he was going around with this, first of all, every student was engaged in that, how did you get started, right? And then some kids were confused, what do you mean, how did I get started? Well, how did you set up your table? He never said, all right, well, when you drew your table, what, like it was, he just asked, he provided a clarifying question to try to get them to think. And every student had the opportunity to express their thoughts on paper. Again, that's a nice strategy because very often what we see with teachers is, okay, so how'd you do the table? And you have that one kid in the room who always has his hand up, and then you have the kid who really doesn't understand what the question even was, and they haven't been given that time. So you talked about that think time before. This is a way to get some of that thought time within the confines of a lesson. Good. Okay, so math practice 5 is using appropriate tools strategically. You need to have tools in order to do that. Okay, that gets into your manipulatives, paper. Yep.
Jen, just going back to math practice 4. I know we don't talk a whole lot about DVDs anymore, but I think that there was an attempt to make it relevant. And then to kind of, it sounds like the previous day task was organized around, so we're going to do like a cost analysis and see if it's really actually worth it. And now you set up the table to discern that, to figure that out. So ultimately, even though it was just a table, it could probably, once they put the information in the table, it gives them some information about whether or not, some information they can analyze. So it's no longer just dancing around in the air. It's something concrete that they can actually look at and decide.
Right, which gets into that like appropriateness and seeing the connections. I'm making an assumption that the next phase of this is now going to be putting this all in a graph and things like that, which then builds that repertoire of modeling strategies. Which one is more effective? Maybe, and then ideally we get into, depending upon the question being asked, this model is better for that versus this model is better for this. Good, yep. When we talk about using appropriate tools strategically, estimation strategies come in here a lot because is the tool giving them what they need. In terms of teacher action, make sure that they know how to use the tools. Okay, that becomes a big thing. That can be very overwhelming. Why are you using that? Having them explain their thinking about the tool that's chosen. This particular lesson for math practice 5 is a geometry lesson. It's about defending properties. What about their use of tools? What was set up in this classroom? First of all, if you listen to the students talking amongst themselves, there was some indication that this is a classroom in which the use of tools is commonplace. Did anyone pick up on some of the language that was used by the students?
Resource manager.
Yeah, there was a resource manager. Okay, you're the resource manager. Can you go get this, this, and this? So that shows that this is probably a routine that's pretty commonplace in this classroom. We witnessed the students using a compass, a ruler, and then this girl here that was in the front, did you hear what she said at one point? I think she had said it was like a spiral or something. It was hard to hear. but she came up with another tool that she thought was going to be important for them to be able to use as they were talking about this geometry. Those tools were provided clearly at some alternate location in the room, but they were available to the students to use. They focused the camera obviously on this one group of students, so we don't know if the other groups were using the same tools or different tools. Okay, but that's that using the tools in order to do the math. Attending to precision, this is really about vocabulary. Do the students understand the mathematical language? And again, this becomes an issue when we're talking about doing this at the younger grades. We very often think, well, they won't be able to handle the math language. So we try to simplify it for them, and we allow them to use terminology that might be inaccurate at times. In terms of teacher action, your teachers need to use the right language. Okay? So sometimes that's building content knowledge of your teachers. Do your teachers understand the appropriate terminology? When students are not using appropriate terminology, does your teacher have ways to reinforce the appropriate use of technology? We're going to skip this video because I'm actually going to go back to the last video that we saw. There was a lot of discussion of appropriate vocabulary there. They were talking about, no, the lines have to be perpendicular, and they're this, and they're that. It was all math vocabulary. Now, granted, that was an older piece, but same idea. I just want to make sure that we can get through most of everything. Okay, tasks for math practice 7, looking for and making use of structure. Can they decompose numbers? Can they take a complex idea and break it down into parts? What the teacher's doing is having them start to look for those things that they recognize from before and then pull it back together for something big. So for math practice 7, let's take a look at what this would look like, because I think practices 7 and 8 are very difficult. This is, again, first grade, working with structure.
All right, so we are going to be doing a number talk, and we're going to be using our base pen.
You saw this part of the clip earlier, but I want to go back to what she started with. If we're talking about math practice 7, which is looking for and making use of structure, how did she facilitate that in that little clip that we saw?
She had the students come up with the solutions and then showed them how they were all the right answers.
Yep. What else?
They deconstructed the numbers so they could see that it could be, 10.
Yeah, so she decomposed multiple ways. One, it was with the 5s, and then, and did you happen to notice when it was the 10s and the 1s, what she put on the board? Yeah, it was using base 10 blocks, right? So she really was showing them that there's so many different ways to do that, and it's all the same thing. That's that getting at that structure piece. In math practice 8, it's look for and express regularity and repeating reasoning. This is your pattern development, and what do those patterns tell you? So you want to make sure that your tasks have the several opportunities to reveal patterns. Based upon those patterns, can they generate a rule that holds for all time? Have students discover that. Okay, I used to do this all the time when I used to teach the rules of exponents. Okay, there's a couple different ways you can teach rules of exponents. You can say, when you multiply, you add the exponents. When you divide, you subtract the exponents. Or you can have the student, I teach a night class to adult learners in a technical education program, and I teach a basic math and an algebra. And we did in algebra, we did the rules of exponents. I made my adults write out how many x's are there, blah, 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 what's your final answer, do you notice a pattern? We did it multiple times, and then they had to generalize. They weren't really happy with me because they were adult learners. They were like, why do we have to do this? And I said, because it's going to stick. It's giving them something to fall back on. So here's another idea in terms of what type of task would promote the structure. So this is track your thinking so you can explain your thinking to someone else. In all these cases, try not to calculate. Really hard for kids when they see numbers, right? Rather, reason about the two quantities. So here's our quantities. Which one of these is greater? That is about seeing structure, okay? For instance, this one. 3 times that quantity minus 2 times that quantity, or just that quantity. Guess what? These are equal, because I see the structure there. Here, if I know about what pi is, this is 4 plus something. Pi is only about 3 plus something. Right? I'm also seeing I'm squaring, so that's never going to be negative. I'm never going to be able to get that down. Right? So that's seeing that structure and doing that reasoning without having to calculate. So what we're doing is that we want the teacher to make sure that the problems assist in making sense. Using those patterns, does that develop that concept better? Ask for predictions. What do you think is going to happen here? What are you starting to notice? Okay, you've noticed that? Keep going. What if we change it from this number to that number? Does that still hold? If we're talking more upper level, if we don't use numbers and we use a variable, does it still hold? Okay, making sure you're building that. And then getting to that point where they can generalize their learning. All right, one last video, and then we're going to talk about the relationship between the math practice standards and Smarter Balanced, okay? Which is one piece of why this is important. Okay, this is a 3rd grade classroom. So I think I hit most of the grade bands with these videos. At least that was my attempt. Okay, so let's think about this. So there's a lot going on actually in that really small clip with this teacher. First of all, her math vocabulary, right? She did not stop. She wanted to get to that commutative property. When the kids said, but you can switch them, a lot of teachers would have stopped there. You're right, you can switch them. That's what we can do in math. But she made sure she was like, but what do we call that in math? She talked about the structure there when we talk about that repeated reasoning and for math practice 8. Understanding that skip counting, if you will, by 5s, even if you have to do it 14 times, is easier for many students, especially in, I think this is 3rd grade, than skip counting by 14, right? Like who skip counts by 14s? Not probably many. Even though I have to do it a lot less, I only have to do it 5 times, it's not as routine. So I'm using the structure of the problem to understand that I can switch the order and I can become more efficient. That's what Math Practice 8 is talking about. Okay? Using the structure to be able to identify how you can do things, and I think she even said it at the end, easier for you. Okay? So, what is our summary of evidence when we're talking about these math practices? Students are doing the work. They're not just mimicking what the teacher has told them to do. Okay? It is not step 1, we do this, step 2, we do this. This is about the students having ownership of their work. Their work includes more than just calculations. So as was mentioned previously, not only are we looking at different ways to assess, we want to make sure that our problems ask questions other than what is the answer. Okay? One favorite question or type of question, which is a pretty easy one to do, you know, Johnny got this answer, Susie got this answer, who's right and how do you know? Or who do you agree with and why? Okay? completely different type of math problem, but it gets at the thinking. Or someone had said before, error analysis problems. You know, Johnny made a mistake in this problem. What's the mistake? Okay. And students ask questions that they're not sure anyone knows the answer to. Allowing your students to have that freedom to ask questions. Will this always work? What if I do this? That requires a lot of math content knowledge on your teacher's part. Okay, so we have to be very careful of that. We finally are going to do this activity. In this envelope are 16 slips of paper. 8 of them are teacher actions. The other 8 of them are student actions. So to kind of pull all of this learning that we've done with the deep dive into one on this paper, I would like for you to look at them and figure out which math practice is being exemplified. And are they student actions or teacher actions? You can work together in a group. Okay, if I can bring everyone back. So we talk a lot about making sure that we model for our students kind of some of what we're expecting. And what I want to point out to you guys as you worked in this last kind of piece, it was fascinating for me to watch the tools that you used in order to figure out the problems. Some people went and pulled out the actual document with the math practices and was looking at all that. Some of you pulled out that question and summary sheet. Some of you pulled out your own summary sheet, but you all were using some resource that was provided to you to try to make sense of this. So that was good. So I will provide you with the answers. Again, you all signed in, so when I get back to my office and I tabulate everything, I will send everyone who's in attendance the presentation and all of the resources, including the keys, to help you out. So the student illustration of Math Practice 1 is understand the meaning of the problem and look for entry points, analyze information, make conjectures, and so on. The teacher illustration of that is to involve students in rich problems, provide opportunities for students to solve problems that have multiple solutions, etc. Number 6, attending to precision, is to communicate precisely using clear definitions, state the meaning of the symbols carefully, calculate accurately, provide carefully formulated explanations. On the teacher side, emphasize the importance of precise communication, encourage accuracy and efficiency in computation and problem-based solutions. Moving on to that next group, which had to do with reasoning and explaining. That's Math Practices 2 and 3. For Math Practice 2, make sense of quantities and relationships in problem solving. That making sense is Math Practice 2. For the teacher illustrations, facilitate opportunities for students to discuss and use representations to make sense of the quantities. Number 3, constructing viable arguments. Use the definitions previously established causes and effects in constructing arguments. Make conjectures and use counterexamples. Communicate and defend mathematical reasoning. On the teacher side, provide and orchestrate opportunities for students to listen to the solution strategies of others. Ask higher order questions and provide prompts that encourage students to think. Modeling and using tools is that next category. Number 4, model with mathematics. Apply prior knowledge to solve real-world problems. That's what we want to see students doing. We also want to see students identifying important quantities and mapping their relationships with tools. For the teachers, use mathematical models that are appropriate for the focus of the lesson. Encourage students' use of developmental developmentally and content appropriate math models. Using tools strategically, that would be making sound decisions about the use of the tools. Use technological tools to visualize the results of assumptions, consequences, compare, make predictions. On the teacher side, use appropriate physical and/or digital tools to represent, explore, and deepen. This becomes really important. Using tools for learning versus using a tool for the sake of a tool are very different things. We want tools for learning is really what using tools appropriately is. And then the last two, seeing structure and generalizing. For number 7, look for and make use of structure. That is, look for patterns in structure, recognizing quantities that can be represented in different ways. Recognize the significance in concepts and models and use the patterns or structure for solving related problems. Teacher illustration, engage students in discussion, emphasizing relationships between particular topics. Recognize that the quantitative relationship modeled by the operations and their properties remain important. And then the last one, look for and express regularity and repeated reasoning. Notice repeated calculations and look for general methods for shortcuts. So instead of giving the students the shortcuts, have them get to the shortcuts. Continually evaluate the reasonableness. And then for the teacher, engage students in discussion related to repeated reasoning. Draw attention to the prerequisite steps necessary and urge students to continue to evaluate the reasonableness of their results. So that was a lot, okay? But that is kind of those look-fors. For those of you who have the look-fors booklet that was done about 5 years ago, in the back of the booklet, this chart is there. Okay, so you guys all have access to it. I will send you the key, but you have access. That, as an administrator or a coach, this is your go-to. What are you seeing? Okay. So the last piece we want to talk about is how does this tie into assessment? Because ultimately, we are accountable to our assessment, right? The accountability scores just came out, everyone's performance indicators, all that kind of stuff just is out now. So how does this relate to that? And why is it important that our teachers are attending to these practice standards in relation to assessment? Well, what we're going to do is we're going to take a look. What I have provided you in Activity 7 is the target language for claims 2, 3, and 4. We talked at the last session that target 1, or claim 1, I should say, that's your concepts and procedures. That's directly from the content standards, verbatim. The cluster heading is the same as the target language depending on the grade level. For claims 2, 3, and 4, no matter what grade level is being assessed, these are the claims. They never change. And it's because they're directly tied to the standards for mathematical practice, which don't change grade to grade. How they look in practice might change, but the actual practices do not change. So what I'd like for you to do is to take a couple of minutes, read through the claim and target language on this sheet, and think about, once you read through the 4 targets of claim 2, which math practice standards do you think that language most closely ties to? And then do the same for claims 3 and 4. So on this activity, it's activity 7. This is the target language. Read through the target language and identify which practice standard is mostly related to that. And try just to use each math practice standard only once. There is one that kind of gets duplicated, but try to use each practice standard only once.
Are we just doing claim 2? Or
You're going to do all of them. All of them. Okay. Yep. Great question. Okay, let's talk about this. So for claim 2, I will tell you that there are 4 practice standards that it is aligned to. Does anyone want to take a guess for claim 2, which practices do you think it aligns to?
1, 2, 4, 6.
1 was one of them.
4.
Not 4 for claim 2. 5. I heard 8. There's one more. If it, no 4 for claim 2. I'm not saying it's not connected at all. If 7's there, which other one is probably going to be there? 8. So it's 1, 5, 7, and 8 for claim 2. Now I heard a lot of people say 4.
Not in that order though, right?
No. That's just for claim 2. So the tools is obviously your 5. Interpreting results in the context of a situation. Some of that is that perseverance piece. Identifying the important quantities, and then 1 is that applying the math practice. So that D really goes with 7 and 8. Okay, how about for claim 3? There are 2.
Before you go there, so target A was what? Target
People
A
want to know
was
for
what?
Oh, you want to know for each one? Okay, it's not a one-to-one correspondence, but in general, target A, applying the math and all of that, that's going to be your math practice 1 in general. Target B, selecting and using appropriate tools, is 5. Interpreting results in the context of a situation, that goes back to 1 a little bit. And then D, identifying the quantities, that really has to do with 7 and 8.
Okay.
So there's not a one-to-one correspondence.
Okay.
Okay, how about for claim 3? I'm going to tell you there's 2 for claim 3. 3 is one of them. And anyone want to guess on the other
I
one?
have 2 and 1 on some of the other things. 2 or 1.
No, you could make the argument that 1 hits all of them, right? Because it's that perseverance piece. But if we're trying to not duplicate here,
2.
not 2. 6. 6 for this one. Okay, so 6 is attending to precision. So let's take a look at this. Test propositions and conjectures with specific examples. That's 3. That's the testing it out, justifying. Construct chains of reasoning. Again, that's with 3. State logical assumptions. Breaking it down. Logic that is flawed. Base arguments on concrete reference such as objects, drawings, diagrams. So if you may have done some modeling with that one, you might have thought that. Later grades determining when an argument doesn't hold. So 6, which is that precision, the reason why that's connected is when you are making your justifications, the thinking behind that is that precision to language. Okay? And then for claim 4, if you've been keeping track, it is 2, 4, and this is where the duplicate one comes in. 5 is also related. So if we take a look here, apply mathematics and solve problems arising in everyday life, you can make an argument for 1. Oh, you know what? There's an error on this. Oh, well, no, I guess not. Interpret results in the context of a situation. Okay, that's that quantitative reasoning. Analyze the adequacy of and make improvements to an existing model. There's your 4, modeling with mathematics. Identify important quantities. That's that number 2. Okay, the quantity relationships. Okay. So again, the purpose in doing this is just that you can see that their language of the target language for claims 2, 3, and 4 are related to the language that you see within those practice standards. So if that's what your students are being assessed on, they have to be experiencing it in their learning experiences in classrooms. Because if not, they're not going to get it.
I apologize. Can we just go over it one more time?
Sure.
Claim 2 is 1.
Claim 2 is 1, 5, 7, and 8. Claim 3 is 3 and 6. And claim 4 is 2, 4, and 5.
Thank you.
And again, you can make some stretches there too, but in general, those are where we at. So we are just about out of time, and I'm not going to keep you late, but just to give you an idea, this is a 4th grade sample item. Pablo solved a multiplication problem using 2 different methods. He made a mistake in either method W or method Z. Identify where he made the mistake and explain what he should do to correct it. If you are not providing your students with opportunities to explain their reasoning, to do error analysis, all of that in the confines of the safe classroom, how would they ever know where to even begin on a problem like this? We have to set those structures up and align our instruction not only to the content that's being delivered, but to the practices that are important. Okay? The last thing that we were going to do, but as always, because that's how I always plan, I over-planned, but we're going to hit on some of these things when we go to the, for those of you that are signed up for the final session, but even for those of you who are not coming to that session, in terms of finding evidence, there is in your packet a copy of Core Action 3, which is from Student Achievement Partners. This speaks specifically to looking for evidence that shows a teacher is attending to the practice standards. There's a rating, and what's cool about the rating is it's a double. Teacher provides the opportunity, and the students are taking them. Okay? Because that's what's going to give you your evidence of how common is it, right? You guys are all administrators. You know when you walk into a classroom that put all the like bells and whistles in it because they knew they were being evaluated that day and they wanted to look good, right? Because the students are like, what is going on? Like they have no clue, right? And like the teacher's like, oh, and da-da-da. Okay, we've all been there. We've all experienced that. So this rating provides a double, because that'll give you an indication of, is this common practice in the classroom, or are they trying to fluff it? Here's your teacher indicators: opportunities for all students to work with and practice course level problems, cultivates reasoning, poses questions and problems that prompt students to explain their thinking, creates conditions for student conversations. Okay, and it's not just tell them what you did, it really is discourse. Discourse is back and forth. It's not just me stating it. It's what do you think about that and do you understand that? And the teacher connects and develops students' informal language to promote mathematical language. Okay, so kids are going to simplify it like in that you get to switch them, right? That's what the little girl said in that video we saw. Okay, she's on the right idea, she's got it, but the teacher continued until we got to that appropriate language. And what do we want the students to be doing? Working with those problems, persevere in solving problems in the face of difficulty. What are the supports that the teacher gets in place to help the students persevere? Okay, even for adult learners, perseverance is hard. When something's tough, sticking with it to get to the end, that takes a lot, right? So what are the supports that the teacher does to help that? Students share their thinking about the content beyond just stating answers. They talk and ask questions of each other. I was in a classroom, I can't remember what district it was in now. The students were like, well, why did you do that? I don't get that. Like it was a lot of discourse. And then students are using precise math language. Are you hearing that? Okay, and again, for those of you particularly that are elementary building principals, where you're going to see a K5 or in some cases a K8 range of what these practices would look like, I really encourage you to look at that progressions document. Because what it looks like in an early elementary classroom is not going to be the same as what it's going to look like later on, for a variety of reasons. That would have been the video we looked at. So again, the emphasis is on students doing and demonstrating their learning. And honestly, that is because we want equity in mathematics. We have to have those learning experiences that are equitable for all students. So we need to make sure that our selection of tasks, our assessment of tasks, and the student learning environment support equity. I don't care what district you are in, what school you are in, all students are entitled to a solid mathematical education because it is the foundation of learning. We have got to change the culture in Connecticut and across the nation that not being proficient in math is okay, because it's not. Does anyone have any final questions for me? This is my contact information. Again, hopefully by the end of the week, I will have all these materials out to you, provided you initialed next to your name. I please ask that you provide me with feedback. I really read these, all of them, every single one I will read and learn from. Thank you for your time. I appreciate it.
Thank you.